we have built a Mandelbrot fractal renderer, and we've built it using this FPGA board. It's programmed in VHDL, and we had an LC3 CPU that was given to us by the teacher as a black box, and then we have built a number of components around it. We had to accelerate the computer, the computer on the FPGA. We had to build a coprocessor to accelerate the calculations of the Mandelbrot algorithm.
So how complex is the algorithm actually?
The algorithm is quite simple, but it takes a large number of iterations. The algorithm had to be run through a lot of times to know exactly what color should be displayed on the screen.
And they are colored after how quickly they tend to infinity.
Actually, the formula is right there on the posters. Zn plus 1 equals Zn squared plus C. And then you iterate that many times until Z tries to escape to infinity. And
which is then colored black.
No.
No?
then you have the number of iterations it took to escape to infinity, and that's the color. If it stays away from infinity, it stays around a small number below 2. Then it's colored black, and that's the Mandelbrot set. That's one. That's where it's. Yeah.
You can zoom on it.
Yeah, it's defined. There's no limit to how much you can zoom in a Mandelbrot set. It's a Mandelbrot fractal. You can keep rendering a new part of the complex plane and see how the Mandelbrot looks like. So you just get more and more detail as you zoom into it.
So how much time does it take to render one picture?
10 seconds.
On a PC, on a modern PC, how long would it take?
It would actually be a bit quicker, I think.
But not much quicker.
No,
the real limitation is the LC3 processor.
Yeah, right now it is. We managed to put 2 coprocessors on along with the LC3 CPU. And the 2 coprocessors together can.
So you can let the whole image to finish.
100 megaflops, and 100 megaflops, that's not a lot in today's computing world. So it would probably be 10 times, 20 times faster in a PC. But this is done on a FPGA board. It could actually. Right now it's rendered in very high bit precision, 64 bits precision in the calculations. We could use maybe 35 bits calculation or something like that. We could have 4 times the performance. And
also the screen resolution is quite high.
Yeah, it's 768 kilopixels. So
no, but pixel horizontal and vertical, how much is it?
1024 times 768.
So in rendering this picture, is there any involvement from the PC whatsoever?
No.
The PC.
So everything happens on the FPGA?
Yeah.
On the computer that you build yourselves?
Yeah.
We implemented a mouse.
There's a C program, of course, that's compiled and uploaded to the LC3 CPU.
But the actual program runs on the LC3
Yeah, it runs
computer.
on the LC3, and it spends most of its time controlling the coprocessors.
We had to create an instruction set for the coprocessors, so the LC3 did not have to feed all the instructions.
Yeah, it can send more commands at once. That was the first bottleneck we found, that the LT3 couldn't feed the coprocessors fast enough. So now it can send commands in bulk, in a large number of commands in just one instruction.
Okay, now, if you look back at this project, what are you most proud of from what you've done?
The coprocessors,
Yeah.
they took a
the
lot of
RAM
time.
implementation,
Yeah,
external RAM.
we had to have implement a frame buffer on the external memory. So we made a memory controller also. That also took some
The coprocessors, they're actually each 32 virtual coprocessors
Yeah.
that we
that's-
can
yeah.
individually write to and read from.
So, yeah.
Okay,